Hello, dear students. Today we are going to solve the past paper, which is 0625 October November 2024, and it's P41. In question number one, a spring is suspended from a clamp. This figure 1.1 shows a pointer attached to the lower end of the spring. Here you will see that there is a pointer which is attached to it, to the spring. A student suspends loads of different weights from the spring and records the readings on the meter rule. So they will use this, they attach here and keep on adding these weights one by one, and they will keep a track on the meter rule that what is the reading on it. And figure 1.2 is the reading weight graph that student obtains, and they then plot a graph between them, between two quantities, that is reading in centimeters and weight in Newton. So using figure 1.2, determine, like we don't need to calculate it, we just see the graph and take a look on the reading on the meter rule when there is no weight is attached to the spring. No weight means like this is the weight here. You can see here we have a zero weight. So we will take a look that what is the value of the reading here. So you will notice that the dot is at this point. It is starting from here. So it is in between the two lines. Here it will be 42 and here it will be 43. So the reading on this vertical axis will be 43 at this point from where it is starting. So we can write here that the reading will be 43 centimeters. The next is a weight of 5.6 Newton is attached to the spring. So you will notice that from here where the 5.6 is, and here it's the sixth line. So you will notice that sixth line is coming at this point. Like it's again 1.5 box. So if you will check from here, it is 1.5 at this time, at this point, and the reading here will be 63. So 63 is the answer for it. It will be very easy for you that you can just make a line with the help of a scale along this line and then take a look on the reading. You will just increase this line till it touches the graph, and then you have to move toward the vertical axis. And when you are moving there, you will notice that what is the value of reading at this point. Okay. So this is the way how we are going to solve it. Calculate extension of the spring when the weight attached at 5.6 Newton. We need to calculate the extension. Extension is basically x, which is equals to the total length minus the original length. So at 5.6 Newton, the total length is 63 and the reading is 43 at that time when there is no weight attached. So when you will subtract these two, you will be able to get the extension, and our answer is 20 centimeters. So you can write here 20 centimeters. That is the extension. Using the values found in A, calculate the spring constant of the spring. We know that the formula to calculate the spring constant is F is equals to Kx. You will separate K from here, which will be equals to F over X. So from here, you can just substitute the values, means 5.6 divided by 20. Then your answer will be equals to 0.28. So what will be the unit for it? The unit for it will be Newton per centimeter. If you want to write it in Newton per meter, then you will convert this first into meters and then you will get the required answer. So to convert it into meter, it will be very easy for us just to divide this vector by 100 and you will be able to get your answer in meter. Otherwise, this is also fine. The next part, C of question number 1. An object of mass 0.5 kg is attached to the spring. Calculate the weight of the object. So we have to calculate the weight here, right? If the mass is 0.50, again, very simple. You know the formula W is equals to mg, right? The product of mass and gravitational acceleration. So 0.50 multiplied by 9.8. You will be able to get the required answer after multiplying these two factors. So after multiplying these two, we will get 4.9, and that is in Newton. The next part of it is the object is pulled downwards until the tension in the spring is 6.5 Newton. They are saying that the object is pushing downward, but this, you know that tension is always opposite the force. So 6.5 Newton is the tension, which is opposite to the applied force. The object is released, and it is released. Calculate the acceleration of the object immediately after it is released. You know that the mass of the object, that is 0.5, and you know that we calculated the weight. The weight of the object is acting downward, which is 4.9 Newton. And as these two forces are opposite to each other, so to calculate the acceleration, we need the net force. So net force is the difference between these two forces. So let's solve this. We will start it from Newton's second law of motion. Acceleration will be equals to force over mass. Force is the difference between these two, 6.5 minus 4.9, and then the mass is 0.50. So when you will solve this, you will get the answer, which is 3.2. And it is in meter per second square because it's the acceleration. So please don't forget to write the unit. Otherwise, you will lose 1 mark. Moving on toward the next question. That is question number 2. The drag force. A drag car is a racing car that is powered by a rocket engine. That is powered by a rocket engine. A drag car accelerates uniformly from rest until it reaches the finishing line. The engine is then switched off and the parachute opens. The car decelerates until it stops. So this figure shows a drag car decelerating after a race. Like let's suppose this is the finishing line, and before reaching it or near it, they will just switch off the engine. The engine of the car is switched off, and they will open the parachute, and now it will start decelerating. They are saying that the mass of the car is 1400 kilograms, and the speed time graph is also given to us. And this is during a race on a straight horizontal track. You will see that its graph is between speed and time. It's speed time graph. And initially the speed is keep on increasing till this, and then it's decreasing like that. So if there is a decrease in speed, definitely there will be a deceleration in it during the curve, and it's not constant here during the curve. Why? Because straight line, it is representing that it's a constant speed and constantly decreasing, or you can say constant deceleration here. But here we have a curve, so we can say that it's not a constant deceleration. So let's see what is their demand. They are saying that the car reaches its maximum speed of 130 meter per second at 6.5 seconds, right? So at this point, if you will see this point, they are saying that at this point, the value is 130. 130. But here along horizontal axis at this point, it is 6.5 seconds, right? This is the maximum value here. They are saying calculate the maximum momentum of the car during the race. You know that momentum is the product of mass and velocity. Mass and velocity. The mass of the car is given to you, which is 1400 kilograms, and its maximum speed, that is 130. So when you will take the product of these two, you will get 1.8 into 10 raised to the power of 5 Newton seconds. Okay, so it's very simple. State the feature of figure 2.2 that represents the distance traveled by the car. You know that from speed time graph, if we want to calculate the distance traveled, it should be area under the graph. Area under the graph. That is representing the distance of it. So we can clearly write here that the feature that will represent the distance traveled by the car, that is area under the graph. Area under the graph, right? Determine the distance traveled by the car in the first 6.5 seconds. So definitely we need area under the graph for first half, for first you can say 6.5 seconds. So if you will take a look on the graph, in the first 6.5 seconds, it is making actually a triangle here, right? So this triangle, you know that if we are going to calculate area under this graph, the shape will be triangle and we will use the formula of half base into height. So by using that formula on this shape of the graph, we will be able to calculate the distance traveled. So let's solve this question. Area under the graph is represented by half base into height. So base is 6.5 and its height is 130. So when you will solve all this equation, you will be able to get the answer, which is 422.5. That is in meters. You can round it off to write 420 even, but it's fine if you will write like that as well. The parachute opens at 6.5 seconds and the car decelerates, right? So the car is starting decelerating. How this figure shows that after 6.5 seconds the car decelerates. So we have to tell by taking a look on the figure. Like it's a straight line, it's a curve, it's increasing, decreasing, like that. We have to explain that. We should use those terms by taking a look on the graph to explain that the car decelerates. First question is that how you can tell that the car decelerates by taking a look on the graph. So you can say that as after 6.5 seconds, I told you initially that speed is decreasing, right? So speed is decreasing here, speed decreases, speed decreases, right? Or you can even tell that gradient is negative because speed is continuously decreasing. Second thing here is that the deceleration of car is not constant as it is a curve, right? So the graph shape is actually a curve. You can just write that it is a curve. It is a curve. So that's why our gradient is continuously changing. That's why the deceleration is not constant. Now they want that we should tell them that what is the energy transfer that takes place as the car slows down. So initially, before starting towards, it's like when they are going to decrease its speed, before it's zero, you can say velocity, the speed is keeps on decreasing when parachute opens. So you can see that it is moving initially. So we can write this thing here that from kinetic to from kinetic store to the internal energy or to the thermal energy, which is the final fate of the energy. Okay. So next question is define the moment of a force and describe the effect that measures it. So to define the moment of a force, you can write that it's the product of force and the perpendicular distance from the pivot. Okay, so you can write, like if you just want to explain this portion of it, you can write that it is the product of force and perpendicular distance from pivot from pivot. Okay. So here, this is the definition of moment of a force. And then in the next part, they are saying that you will describe the effect that it measures. So it measures actually the turning effect of a force. So you can add this thing in it that it measures the turning effect of a force, turning effect of a force, and how you are going to measure, you can write the equation for it. Okay, so moment of a force will be equal to moment of a force will be equal to force multiplied by the perpendicular distance, right? You can add from pivot even, no issues at all, from pivot. But this perpendicular word is very important for Cambridge, and it is underlined sometime in the marking scheme. So if you will not write this, definitely you will lose the mark. The next part in it is a large rectangular block. Here, this is the large rectangular block of stone, has a square base of side 3.4 meter, which is given to us. Figure 3.1 shows the block at rest on a horizontal surface. So you will see that this is the horizontal surface here on which the block is resting. The block is of uniform density and the center of gravity is at its center, exactly at its center. They are saying that first of all, we need to tell that what is meant by the center of gravity. The center of gravity is the point where the whole weight of an object is acting. Okay, so we can write here it is point in an object. It is point in an object where all the weight of an object of an object of an object seems to act seems to act. This is called the center of gravity. So if we will write this, definitely we will gain the mark. The next part in it is that the weight of the block is 1.3 Newton per 7 Newton. Calculate the moment of the weight of the block about the corner x. Means that this corner x is pivot, right? And we have to calculate the moment about it. So come on, and we will take a look on the figure now. And you will see that this is the pivot here. So I'm writing pivot at this point. The force, that is the weight, actually is acting downward, and they are saying that its value is 1.3 into 10 raised to the power 7. 1.3 into 10 raised to the power 7 Newton is the force which is acting downward. And you know, it's the product of force into the perpendicular distance. So this is the perpendicular distance till the pivot. Here is the pivot, so distance from here till here, we actually needed that. But you know that here they will give us the total distance. So our first step will be to divide it by 2 to get the half of this distance. Okay. And then we can use the formula which I have written here, force into perpendicular distance. We will take just simply the product of them and then we will figure out the answer. So I'm going to solve this. I think it's better to solve here. 3.4 divided by 2, you will get almost it is 1.7. So this distance starting from here till here will be 1.7 in meters. And then later on we will use the formula. So here I'm writing the formula, that is moment of a force is equals to force times perpendicular distance from the pivot. So force is 1.3 into 10 raised to the power 7 multiplied by 1.7, which is the distance between the weight and the pivot. So when you will multiply these two, you will be able to get the answer, which is 2.2 into 10 raised to the power 7 Newton meter. Moving on to the last part of this question. The block shown in figure is in equilibrium. State the two different conditions that apply when an object is in equilibrium. So the first condition of it is that resultant force must be equal to zero. Like you can say that if this is the block here, so all the forces which are acting on it should be equal to zero. For example, this object is lying on a horizontal surface, so the weight of it is acting downward and the reaction of the table or the horizontal surface is upward. So these two are equal and opposite, so that's why the resultant force is zero. The first condition is also fulfilled. The second condition is resultant resultant moment resultant moment is also equals to zero. Like the clockwise movement and anti-clockwise movement, these two should be equal. So clockwise movement or anti-clockwise movement, both of them are here equal to each other. That's why we are getting the resultant zero and the object is in equilibrium. So till here we have completed our three questions. Moving toward the fourth question, describe an experiment to determine the specific heat capacity of aluminum. You may draw a diagram, include in your answer the measurement made and any equation which is needed, and this question is 4 marks. So let's start there. They specify the aluminum. You know that aluminum is solid in nature, so you can take a piece of an aluminum, maybe cylindrical in shape like that. Okay, you can drill two holes in between them. One hole to insert the electric immersion heater in it, another one to add the thermometer inside in it, just to make the readings, like that to calculate the specific heat capacity. We need what we need actually. First of all, I will write the equation, then it will be very easy for us to understand this equation. We need C is equals to, C is representing specific heat capacity here. E is the total energy divided by M, and then change in temperature. Change in temperature includes the initial temperature and final, means final temperature minus initial temperature. So these are our requirements. Like first of all, let's suppose if we want the use of a thermometer, you can write that initially before starting or before switching the electric immersion heater on, we should measure the initial temperature of it, okay? And you will switch on this electric immersion heater. Let's suppose for known time frame, that is for 5 minutes or like that. You can use the stopwatch here to measure the time frame for a specific time interval. Because to calculate E, we need power and time. So power should be known for it, for this electric immersion heater. It must be written sometime on the heater. And then time, definitely with the help of a stopwatch, you can measure it. By using this equation, you are able to figure out the value of E. You can substitute here. Mass of the aluminum can be found with the help of a top and balance, which is very easy for us, and then change in temperature. So utilizing this equation, finally, you are in a position to figure out the answer of the how to measure the specific heat capacity. So these are the steps. I hope that you can write it in your own words. So moving on toward its B part, here they are saying that an aluminum dish is initially at room temperature. So this dish is made up of aluminum, this one. Boiling water is poured into this aluminum dish as shown in the figure, and they are saying explain why. After a short time, the dish and the water are the same temperature. So they want that we will write that why these two are at the same temperature. So there are a few points which definitely help us to explain this answer. Number one, transfer of energy from water to dish. Like, let me tell you, you are pouring this water here. This water is transferring the energy to the boiling. This transfer of energy is there from water to the dish, to this aluminum dish. The water is transferring the energy here. Secondly, you can write that this energy is transferred with the help of a conduction. Okay, so you can tell that this is because of the conduction here. One more point you can add in it, the temperature of water decreases and temperature of dish increases, right? So these are the points which are important for us to write it down, that how the energy will be transferred in it, and how the water are at the same temperature, dish and water. And finally, you can say that at when both of them are at equal temperatures, and there will be no transfer of energy at that time. Uh, Second part, explain in terms of its particles why aluminum expands as the boiling water is poured into the dish. So definitely as temperature increases, you know that the molecules, they will start vibrating, and when they are going to start vibrating to and fro from their initial position, definitely the distance between them keeps on increasing and it helps them to expand. So particles gain energy in kinetic stir. There will be separation of aluminum particle, must increases. They are moving further apart from each other. The next part of this question, which is the final one, the water in the dish evaporates. Explain in terms of the molecules what is meant by evaporation. It's very, very simple that how the evaporation can happen. You know that in evaporation, most energetic molecules, they will escape from the surface. So let's suppose if this is the dish, here we have the water in it. So the most energetic one will escape from the surface, right? And leaving behind the less energetic molecules, right? So in this way, you can explain the evaporation that most energetic molecules, they will escape from the surface and leaving behind the less energetic molecules, all right? So for solving my next part of this paper, starting from question number 5 till 9, you can please watch my next video. If you like this video, please do press the button of like and subscribe my channel. Thank you.